let's start with any company update.
Yeah, so I think we got an office in Hong Kong from the 10th for a month. So from March 10th to April 10th.
We might need to extend that for another 2 weeks. I will be there
Another
in.
2 weeks. Oh, well, I'm not sure I'm going to be here after April 10th, but
Oh, you are not? Okay, let's discuss
uh
it offline.
yeah, we can discuss this offline. Yeah. Well, I have to make it back to San Diego. But
Okay.
yeah. So we have a big office. We got a bigger office this time. We got it's nice in this nice co-working space. So if anyone is interested in a job, solve some bounties quickly, come out to Hong Kong, hang out with us. Yeah, we're mostly a remote company, but we sometimes get together in person. We have in-person stuff in San Diego and in-person stuff in Hong Kong. So yeah. I think we'll be able to extend it though. We'll see. I got a very good deal because I only booked it for 1 month. Uh,
Interesting. Isn't it
so
usually the case that if it's shorter, it's more expensive?
well, yeah, but they have a lot of empty offices in this building,
I see.
so I got a really good deal. The other company update is Intel actually came through. Yeah, Justin Long from Intel actually came through, and we got some samples. So we have two Max 1450s and a Max 1100 on the way. Potentially with a lot more Max 1450s to follow up. Intel did make big GPUs. They just didn't sell them as consumer GPUs. The Max 1450 is, again, the software is going to need a lot of work, but from a hardware perspective, it's as good as an H100. So yeah, somewhere between an A100 and H100. But yeah, so if the stars align, we'll be able to purchase a lot of them, build some blue Tiny Box Pros. Yeah, and if they don't, well, the AMD stuff looks okay. The new AMD stuff looks okay.
Sounds
But
good.
yeah, these samples are real. We'll bring them up in computers. We'll start to play with them. It really is. They really are sweet GPUs.
Sounds good. Okay. That's company update. Let's move on to Torch's front end. I
Yeah,
think
this is
we have I don't know, for the new people here, this is a project that you can write Torch code, and with, I think, 2 lines, you can use Tinygrad for its device or for its backend, and your Torch code will run on Tinygrad, which run on the devices that Tinygrad supports. So definitely not Nana GPT.
uh,
So I think
yeah,
MNIST works now.
MNIST works, ResNet works.
Resonant inference work.
Nano GPT kind of works. It's using a lot of RAM, and we don't know why.
No, there's update on the PR.
We
There
know why.
there was a
We know why.
there was a memory leak.
Great, and we fixed it.
I think he said there's a like workaround something.
He's a speaker if he wants to say something. Oh, I see. Yeah, cool. Yeah, I think this is on the right track. I think yeah, we fixed this. We fixed whatever the memory leak is. And we don't need to. I don't think implementing AMP is part of it, but I think fixing the memory leak is part of it. But yeah, no, when we're done with the Torch front end, it's going to be 0 overhead. So there's no downside to using Torch as a front end. Like once it's in TinyGrad, it all perfectly you get all the same speed ups. It's not like the Torch thing's gonna be really slow. So yeah, it's gonna be a good front end.
What do we want to handle for things that we don't support?
Like
Say the
what?
things that has data dependent shape.
Oh, I mean data dependent shape. Yeah. I mean those have to be graph breaks. We can support them, but they're graph breaks.
Okay.
Like it's gonna realize and stuff. I think that's fine. But yeah, we shouldn't really have much data dependent shape stuff. But yeah, things like top K, I mean, we just need to implement. So
Top K is fine. It's more of like
and
non-zero and some mask select thing.
yeah, I mean, there's no reason we can't get test ops working first. Like all of test ops obviously has to work because it works in TinyGrad.
I think that is making good progress. Last time I saw there's only 10 failure. I don't know what the number is now.
Great.
Mm,
I think there's some progress on multi GPU too. So
yeah. So Torch compile, I think
I wrote
Torch
a
comp
very I wrote a skeleton for it. If someone can clean that up. I mean, you don't really have to do anything that different with Torch Compile. The only thing Torch Compile really does is runs the Torch function decorated with the TinyJet. Torch Compile also takes care of all like the PyTree stuff for you. So it works really nicely with TinyJet. That just needs to be cleaned up a little bit more.
How does that work? Do we need to update our JIT so that it's not running like different things the first time and the second time?
Uh, we can make the compile not have overhead. So like right now, the compile runs it 3 times. Eventually, I want to update our JIT not to do that, but I think just like running it a few times is not that big of a deal either. We can also just like not run it in the compile, and it can only be fast on the 3rd time of compile. It's just important that compile actually decorates it with the TinyJet and gets the inputs and outputs to be like expanded, which Torch compile does for you.
Yes. Cool. Yeah, I think that bounty is also going. And finally, the memory intro.
Interrupt me?
No, the memory interrupt for Torch Tensor and Tiny Tensor.
Oh, yeah. I think that's merged. I think Nimble merged that. You can just do dot from blob on a CUDA, and you can import it. So if you have like Torch CUDA, you can like import it, the memory.
Okay, sounds good. Yeah, so I think the immediate next step is multiple bounties that I think this direction somehow a lot of new people are contributing, so that's always nice to have, nice to see. And do we have any? Let's get the feature to be more complete, then we can think about the speed issue on this. Is
Yeah,
there any other popular Torch script or Torch thing that people run that we also want to check it running?
like NanoGPT and HLVC for I think Fast GPT is another one. I think like all of these common Torch things. I went through all the Torch examples and tested them, and like most of them worked.
Oh,
There was only like
someone mentioned the Stable Diffusion large can work with Comfy UI. So now you can use the Comfy UI workflow and use TinyGrad to run the image gen models. I thought that was pretty cool.
great. Yeah, it shouldn't be like slow either. The backend should be pretty decent.
What happens
already.
if a torch project uses Triton or CUDA binding?
Well, so it doesn't use. That's not going to work. Yeah, it
Yeah.
doesn't use Triton or CUDA. It's Tinygrad. It's totally separate. Like if you're using Triton or CUDA, you're using the CUDA backend. You're not using the Tiny backend. Tinygrad is like a new device. You do like .tiny, device equals tiny, all that stuff. So if you want raw CUDA, you're going to have to do it using like Tinygrad's abstractions, not Torch's abstractions. But yeah, no, for now, that stuff's not going to be supported.
Yeah. And are we going to support it? Probably no.
Probably no. I mean, I could see a world in which we support something like a custom kernel that can go in our graph, and then maybe for things like flash attention, it could work. But this is not anytime soon. Maybe someday,
Yeah.
but not anytime soon.
Yeah. For now, we are using Torch. What Torch Express? It's a layer of about, I don't know, 200 functions, and the idea is if we implement those functions using Tinygrad code, then it kind of just work. Any custom stuff or any backend binding won't work anytime soon. Okay. That's it for the Torch frontend. So action item for people here, you can find your favorite Torch script that's written in Torch and add the install Tinygrad, add the 3-line change to the project. Basically move all your tensors to device tiny and see if it works. If not, just shout somewhere.
Yeah, if it's like a normal Torch project and you want to post an issue, we'll look into it.
Great. Okay. Uh, let's move on. Quantize debug. I guess fast jam because you do something.
Yeah, I did a stream this weekend with Fast Jam. The quantized DVAC is something that I've been working on for the DSP, but I'm finally just doing it right. So this is something that's been wrong the entire time. Basically, to do load store grouping, I was doing the load store grouping on loads and stores, but now we have this index UOP, so I've moved it to the index UOP. It's faster. We get about a 5% speed up to everything by doing it this way. And then we also don't have to devectorize. We might not have to devectorize anything. Like you can with the DSP, you can't devectorize. Maybe you can devectorize the indexing, but if you devectorize the actual math, it will never be fast. You have to keep things in 128 element vectors. So I wrote this whole thing to revectorize, and then I'm like, this is stupid. We just need to never devectorize. So that's what this new it's basically just it's called expand index, and what it does is if you're loading from memory addresses 0, 1, 2, and 3, it groups them together into a float 4 load, and it does this without needing to see the loads, but it does this while it's still in indexing. So it's faster, it's cleaner, and it allows you to keep all the math still vectorized, which with some backends like LLVM and Clang just totally works fine. So it makes rendering the kernels a lot faster. It gives LLVM and Clang hints to do things. So it should just be way better. I got most of the bugs fixed. I have a few minor things with image still to deal with. Stupid image. But every time the hacks for image get a little bit smaller. So that's good.
Great. Speaking of image, did you see comma like did a big cooling out because Tinygrad?
Oh, they're using are they using Tinygrad down CI for CPU?
Yeah.
Oh, that's great. Yeah, I mean, once you're in Tinygrad, it kind of runs everywhere. So that's great. I'm glad to hear they're relying on it more. And our dream is to get Comma to switch to Tinygrad for training. But now it could just kind of work with the Torch backend.
We should get their Torch code and see if it runs.
Yeah. I mean, this is especially going to be interesting if the Intel thing works out. The Intel thing works out, Comma's about to get a whole lot of Intel GPUs.
Okay. How fast was the gem get?
So, I mean, I copied his stuff in exactly. So if you use his assembly, you get 40 gigaflops, 40 teraflops. So it's like twice as fast as what's in Tinygrad now. It's like
Oh, that's
50%
for
fast.
Flow 32?
Flow 32, yeah.
Okay.
Yeah. So it's like twice as fast as what's in Tinygrad. It's like 40% faster than what's in RockM. So I basically just extracted the tricks. The main trick that we're not doing in Tinygrad is we're not using shared memory. We're not using, it's called like shared and CUDA, but it's like the local memory. We're not first copying the stuff into SRAM. So I want to finish the quantized stuff, and then I want to add that as a search. I want to add that to Beam. I mean, I was like messing around with like trying to do it by hand, but I'm like, no, I just need to like write this correctly, add it to Beam. Beam will find it. Then there's that optimization. Then there's the double buffering optimization, and then our gem should be 40 gigaflops, and that'll be faster than RockM. It should be fast on
Great.
CUDA too. Yeah,
That's good. You have 4 more. You have, I don't know, 4 weeks for the contract.
Yeah. We have till the end of March for the DSP contract. That's I really got to work on that. Yeah, it's hard. The DSP represents the pinnacle of difficulty. I talked about this a bit on stream. It's SIMD and not SIMT. So you actually have to deal with all your loads and stores in a vectorized manner, and then you're using like shuffle units to put things in the right place. Whereas GPUs, you never have to think about any of this. You can just do like 32 different loads, and the memory coalescer will either hit or miss. So yeah, it's a lot easier to get performance on a GPU than it is a Qualcomm DSP. But if we can get performance on the DSP, it's looking really good for everything else.
Sounds good. Okay, before moving on to my stuff, I want to ask about TensTorrent. Wrote attention in SRAM on TensTorrent paper and implementing AlphaPort 3 on TensTorrent wormhole.
Where is this?
In the Reds Only VC chat.
Oh. Any update on TensTorrent support? I mean, we have a bounty for it. TensTorrent has backed up. TensTorrent has backed up our bounty. Core6 has backed up our bounty. So you can make some good money if you actually support TensTorrent's cards. Like with all the people supporting it, it looks almost like you're going to make like 5-6 grand.
And now with Torch as front end, this will be extra useful for everyone, I think.
Yeah. So Tinygrad basically like we should have done like Torch's front end was such a good idea. If you implement a tiny backend now, you're going to get Torch, Onyx, and Tinygrad, and you're going to get the other ones. Like Torch and Onyx are basically free. So, but yeah, someone's got to do the TenStorm backend. Moritz, if you wrote the paper, I mean, it sounds like you should do it.
Yeah. I think for now it's just it's a thing that we can incentivize through bounty, but not a thing that we actively are trying to do.
Yeah,
No.
we don't have internal company resources to put on it, but I'm happy to put a few $1,000s up for it. It'd be cool to do.
Okay. Let's move on. Bird. We have our first sub 4 hours wrong, so 3 hours something. There are something. So for now, the run is about 4 hours green, and I think 5.5 red. So red are a little bit slower. I was trying the SDMA bind thing that Imogen suggested, but I keep crashing my machine. So no
So
update.
it's only crashing with bind.
So far, yes. It crashed twice, and these things only crash after a few hours. So,
Nimiljan, can you explain what SDMA bind is?
So yeah, basically it uses indirect execution on the HTML queue. So yeah, we're just not, yeah. But actually, I think that's just kind to. I think like it's a bit deeper problem and not related to these DMA like indirect execution. I've noticed it several times. I think it's something with the ordering and the like how like what data is sent to the GPU and what GPU sees. Because first of all, the main difference is that we use queues which are so only for AM we use queues which are like physically allocated on the GPU, like not on the system RAM but on the GPU. So we just like when we need to write into the queue, we just push into the device and not device pulling from the system queue. So, and I'm not sure that it's so that's the main difference with the AMD backend. And
is there any reason we do it differently? Is there any reason we don't just use system RAM?
um, actually, I think that it's just safer because we just know that it's like we cannot think about caches on the system level. But yeah,
but
maybe we have to switch it.
now you have to
Yeah.
think about caches on the CPU, on the GPU, right? Like if you do a write to the GPU, does that actually end up in the RAM?
I mean, that's kind of strange because they try to implement the same feature in the ROC R runtime, and it's still on their plug, and there are some issues that it doesn't work for them as well. So I don't know, maybe it's something. So I don't know, maybe it's something with the GPU missing because for these features, actually, you need interrupt handler to be enabled on the GPU. So if it's not enabled, so like interrupt handler is somehow important for this part. So, and yeah, if it's not enabled, it will hang after some time.
I mean, it should just basically be a one-line change to throw it in pinned memory on the CPU instead of GPU memory, right?
Yeah. So we already have this flag to do this. So, yeah.
Got it. I mean, we should be fuzzing this. Like we should be able to, we shouldn't be finding things like this on a BERT run. We should find things like this in a fuzzer.
Yeah. I mean, yeah, I know about this problem and we have fuzzers. So just to send these signals, I think it was fine for like several dozens of hours. But I think it's also related to like the size of the queue and how, yeah, I mean, it's related to the size of the queue.
Let's figure out, I think top priority is figuring out how to get our fuzzer to replicate this crash.
Yeah, okay.
Any data we have on the crash or anything, like let's get this replicated in our fuzzer and let's truly root cause this, because right here is where we have the ability to completely outshine AMD. We can root cause this, we can figure out exactly what's going on, and we can fix it. And then we can write regression tests such that it never happens again. Regression fuzzers such that it never happens again. This is the highest priority, and this right here is why we beat AMD. Like we can do this.
Yeah, sure.
Okay. For now, the best repro I can give you is SDMA bind equals to 1, and it crashed for me twice, but it's only after 5 hours.
Mm,
I mean, I don't know. I mean, I can try different stuff if you have any instructions for me, like some debugging flags or something. So maybe I can log more stuff.
I would also just like the way that I would probably go about this is like take BERT and just say, okay, what if we don't run any of the compute kernels? Does it still happen?
Um, yeah, I mean, so yeah, not exactly for the team, I think, but okay, yeah, okay, yeah, that makes sense. Yeah.
Does the fuzzer cover multi-GPU?
Yeah.
Okay.
So it's basically like the fuzzer. I'm just fuzzing signals there because
Oh, I
we
see.
had,
Okay.
yeah.
I think we gotta try like my guess would be that there's some cache that's not coherent here. That there's some like I know PCIe has a cache. I know the GPU has caches all over the place. I mean, I don't even know really like what's doing the reading of these queues. Does that thing have a cache?
Oh,
Yeah,
yeah,
you see what I'm saying? Like, is it the MEC? Like, does the MEC have a cache?
yeah, that's interesting. But
What
actually, I think
actually?
it's, yeah. I mean, I had like yeah, I've seen that crashes, and I mean, the reason we see hang is, sometimes we can see page fault because it just takes only the half of the address, and the other half is 0. So I think it's like not filled with data. It's not really cache. I mean, it's just GPU doesn't see this data
Yeah.
because sometimes we see, yeah, some half like completely 0.
Okay.
Yeah, I think I can also, yeah. Okay, so yeah, I'll focus on this.
Cool.
Cool. Okay, sounds good. So I'm running out of tricks to make BERT faster. The most immediate one I can see is random should be in one kernel, and now it's 3. It's 3 because it has an A range to start, and there was a trick to cut the random into 2 parts, then combine them together, and there the cat generates one more kernel. So I like to make that one kernel because range should be one kernel. That requires fuse A range. Fuse A range sometimes in other place has other issues that I don't know, but it should work with rand.
Oh, I
Yeah,
guess.
but after that I don't have other. The birds looks pretty lean right now. It's just things are not fast. Even the forward is not fast.
Wow.
So forward is about I think 300 to 350. So that's like 30 something percent utilization. And inference doesn't use random.
Why is it slow? Is it the gem that's slow or?
I think gem is slow. So our gem is only in our benchmark, the gem is only fast if it's really, really big.
Do you want to post the size of the gem? And I can just look into that.
Sure.
Like, yeah, if we could get some like micro benchmarks, maybe. Like get some like micro benchmarks. You're like, you make this faster and BERT will get this much faster. I could take a
Yeah,
look at a bunch of micro benchmarks.
I was doing that by stripping out components to the layers so that it's only gem that's left. I can post the size, or I'll have a script that kind of replicate this.
Yeah, like, and I wonder how bad is this gem? Like, how many teraflops per GPU?
We have multiple, so I need to take a look. We have multiple with different size.
Cool.
Yeah, so yeah, I'll probably be focusing on rand one kernel, and I'll see what's the issue with fuse A range. It sometimes works, sometimes fail.
Yeah, we probably just need to expand that pattern a bit. Sure you could do that.
Yeah, I think I'm not too sure about the current way it's done. So the current way it's done is too loose, I think, because it will fuse too many stuff still, but I'm not too sure. Anyway, we're looking.
We could also potentially put reduce back in. I don't know if this helps at all, but like right now we're doing the thing with like define ACC and assign and stuff. Like we could potentially do graph rewrites while it's still a reduce op. I don't know if that helps.
I'm not following. Which is this?
So like we do in lower, we rewrite the reduce access to a define ACC, add, and assign. We could potentially bring back the reduce op, which is just like a reduce, like a reduce access op. And then that might be easier to see the A range pattern. I don't know if that actually helps.
Interesting. No, now it fails at higher level. Now it fails at scheduling.
Oh, it fails at scheduling. Oh, that's okay.
Yeah. So there's that. Oh, speaking of reduce access, do we want to match the torch behavior that empty string is everything? That feels weird, and it's not documented anywhere.
I agree that it's weird, and I wasn't thrilled about the hacks to do that. I don't know. No, I don't think it's right. I don't think we should match that behavior. If it's not documented, I don't think we should. We'll just do it by torch.
I was checking torch. I was checking some like their documents, and it only says it's reduced over the dimensions if it's a tuple. So by that definition, empty should be nothing. That's what we are doing now. I think this is quite obvious because the output shape would be different. So I don't worry too much if people use this wrong.
Yeah, I mean we should just hack it in the torch front end then and say this is just to match torch's behavior.
Okay, great. Now speaking of this, do we want to support the low level shift stuff? So we want to shift stuff in the tensor level, like tensor left shift to another tensor and things like that. And so your to do.
Yeah.
Do we want to support this, assuming the support on device?
Yeah, I mean you can also just use POW for that.
You can use PAL. I don't have a clean PAL for that now. I mean the multiple, like multiply to like exp2 to the thing.
Yeah.
But that's in there. You need to do the big cast, then big cast it back.
Yeah, I don't know. We should just support it. I'm fine with adding it to the backends. Like we should like support shift and do like a rewrite if it can't do it. I don't know.
Maybe big cast is fine. That sounds
Yeah,
faster.
no, I mean the important thing that what we have to do is we have to just get tensor working with shifts. Like we should be able to shift tensors and stuff.
Okay. Yeah, that's something I can do, or I can find someone to do.
Cool.
Cool. Okay, let's move on to schedule.
Right. Last week I merged Casper for back, so I think that got some speed ups. We also have fast viz now, so you can actually like viz the beautiful MNest and BERT. Hopefully that'll help us figure out where the gains are gonna be. I'm still so I merged something that would get the kernels down for BERT, but it actually made step time slower. How would we like do the benchmarking on these? Because like right now, I think we have enough infrastructure to mess with these expands, but like we don't actually know which ones are high leverage and valuable. Like, do we need a memory profiler? I could work on that.
Oh. Yeah, I think the memory profiler would be a good idea if you want to get a flame graph up for memory.
I think we have to, like, do we understand why some expands are slower if we fuse them?
So one major case is, I think it's because the safe path thing, so some tensor core would be disabled. So things that were previously triggered tensor core no longer triggers tensor core. That's one. For other case, I don't know.
Oh, if we like put the expand and we're doing the math before the tensor core, maybe it doesn't trigger the tensor core.
Yeah. That's one common issue why certain kernel becomes slower, or certain parts of kernel become slower.
I think that we still have more infrastructural stuff to do before we I think the memory flame profiler is a good idea. Also, how is becomes map coming?
I'm gonna work on just refactoring the entire grouping part. So yeah, it's in progress. I'm gonna keep on working on it this week.
Cool.
I think I'm making good progress with it. But yeah.
I mean, I clicked the profile button on Viz, and I think particularly this is something I'd really like to do in person. Is think about what the unified Viz is going to look like. So right now, Viz is like visualizing the compilation, but it's not visualizing the runtime. I guess the memory is kind of part of the compilation. So we should think about how we want to visualize the memory in that graph. Like the memory is determined by I was thinking about it. You really can see it on the beautiful MS. Like your memory is determined by all your long edges, and you could imagine like sliding across the thing and like drawing a line down the graph, and everything that intersects has is using memory.
Mhm.
But yeah, I think so. I think like we still need more visualization stuff and more scheduler refactors before we can really start like fully talking about the assign. Is multi-output kernels back?
Like it requires first refactoring the grouper. Yeah.
Okay, cool. But yeah, grouper refactor becomes map. Nice to have cast before view back.
Oh yeah, and nice job isolating why GPT-2 becomes slower.
Yeah.
Oh, what was it?
That was it was wasting time doing reshapes. Like it's so good we have process replay on the scheduler. So it goes from tensors from the big sync to the scheduled item ASTs. So you could actually like see the diff that it was doing reshapes, and it shouldn't do that.
Cool.
Yeah. Right.
Okay. Becomes map and multi-output rollover. And view is gone from the kernel graph?
That also requires again doing that. I was thinking about actually like subbuffer. Subbuffer is just supported on some devices. Like the offset function on the buffer is not supported. Do we want a fallback in those cases? Because like what I want to do really is like in the schedule item buffers, I want to put the subbuffer instead of the actual base buffer for an set item.
Which devices don't support it?
I think GPU hanged. It was like offset function doesn't.
I think there's a way to do it. I think maybe we should just add support to it and require it in the back end. Yeah, it's called CL create subbuffer.
Cool.
Probably should add support for it.
I think that was the only blocker from the JIT side, but other than that, it's mostly the scheduler refactors.
Cool.
Cool.
But we still got rid of most of the views, right? Or are all the views still there?
The views are still there. It's an all or nothing thing. Like I can't do partially remove things.
I
Like, I
see.
want to do it. Yeah.
Yeah. Now, I don't really know like what is the current behavior if we don't support subbuffer?
Like there has to be some way that's set item is expressed in the kernel graph.
Well,
Because the
you could
buffer
always
size is smaller than the kernel size, right?
you could always like you could always merge the subbuffer in, right? So also, actually, let's be precise here. What is supported on every device is a smaller size. It just doesn't always support an offset. Does that solve the problem? Right? Because you can always just imagine it's smaller, right? There's no device where if I pass in a buffer that's size 200 and it only accesses the first 100, that's going to do anything bad. It just needs the offset. But the offset's what you need the function for.
Yeah, but you need the offset if your shape tracker is an offset, right?
No, you can always put that offset in the kernel, right? I'm not exactly sure why you even need subbuffers. Like in the, I
Because
understand why there's some.
I want to literally take the kernel sources and materialize those buffers in the schedule item. You see, like, I want the kernel sources to be the correct representation of the buffers that are in the schedule item.
I think the first thing to do here is to write some tests for the current subbuffer behavior and make sure we understand like all the different cases it can trigger in. I know sometimes we were using subbuffers to replace bitcasts, right? Because you could also replace a bitcast with it.
Yeah, we do that for disk.
But I think we should just like we should document the behavior of the current subbuffer first. Because I don't really like the idea of having to add it to OpenCL because I always want backends that don't support it to just not support it, even if we could. Yeah, but no, I don't feel that this is necessary. I don't feel that supporting subbuffer is necessary to remove view from the kernel graph.
It's not.
Yeah.
Yeah.
Let's figure out how to do it with it. Let's figure out how to do it without that. But again, becomes map and multi-output are higher priority stuff.
Yeah.
Okay, let's move on. Imogen.
Yeah, so I'm going to look into the AM, this problem. What we talk about also the MSP. So yeah, 4 AM it just helps people with the AMD for some reason.
Oh, is this why the ring is slow?
Yeah. I mean, yeah, it reaches like 7 gigabyte a second, while AMD is 14. About
Yeah,
14.
Do you know why?
So no, not
Cool.
not
Yeah,
yet.
that's
So
a good,
yeah,
that's a good thing to look into. And then why is our disk only getting 10? Why can't we get 20?
Yeah, I haven't looked into that yet. But yeah, I've run it and it's about like 11, 12 weeks. Yeah, I think we can get 20. Yeah,
With DD, I can
definitely.
get 20.
Mm-hmm. So yeah, okay, I need to look into that. What's the
Is there any
bottleneck
DMA?
in this?
Is there any way to DMA directly from the NVMe drives?
Yeah, like in theory, yeah, of course, but yeah, I'm not sure there is some API for this for like for the IO ring because I need to double check. I think yeah, definitely like in
I mean,
theory, hardware can do this, yeah. But
yeah, like I'm even just saying, like in IOU ring, what if you literally give IOU ring a GPU address? Does that work?
so I think yeah, if I give an mapped address to the PCI bar, I think yeah,
Like that'd be
will.
sick. If you could just tell the like don't even go through system memory, just literally tell the IOU ring to put it to the GPU.
Yeah, I need to play with this.
Cool. But yeah, no. Fast. First priority is bugs and fuzzing, fast ring reduce, and fast drive load. What I'm gonna do after that drive load benchmarks fast, I'm gonna run the I'll run the PyTorch loader on the GPU. So like instead of loading Llama like we're doing right now, we load one weight at a time. That's always gonna be slow. Just copy the whole PTH file to the GPU. Oh no, we wasted a few megs for offsets. Who cares? And then do the load and split them all into subtensors on the GPU. Like that should let us load things so fast.
Yeah.
But yeah, cool. Sounds like a good priority list.
Limoja, how did you fix the tiny 19 issue? Because
So
now it's 5 GPU again. I'm not sure if it's really fixed.
so no, I just did reboot like the off and on.
Okay, yeah. So that's also what I did. Then initially it would show 6 GPU, but once I start to run BERT, it hangs, and I check again, it becomes 5 GPU.
Yeah, I mean, well, I've collected logs, and actually, like the GPU simply, like there is some information in the mask that GPU just fall off the bus, and it's
Yes.
all these cases are just the same GPU. So I'm just do a run right now, monitoring temperatures. So maybe that's the reason. I don't know.
Okay, sounds
Yeah,
good.
but so far it's good.
Okay. Okay. Now we have 10 minutes left. Let's give a like quick update on some of the ongoing bounties or works. Let's start with Tiny Chat.
Hey, yeah, so I did everything I wanted to do. The PRs have been ready for review for Tiny Chat for a few days now. I saw Chenyu merge the first one, thank you. That covered the changes to Llama. And then there's the remaining two parts for the Tiny Chat bounty. The remaining two PRs that are awaiting review are covering, how we compile and export the Tiny Chat model in a way that's suitable for the browser. And then the final PR is, the browser app. So just waiting for feedback on that.
Sure. First, do you want to review or take a look?
Yeah, I can do this.
I think it's fine mostly, but I don't know too much about WASM.
Yeah, I can review this tomorrow.
Okay.
It looks pretty
Yeah,
good though.
there's instruction for like how to run the script to like reproduce the code. So.
Yeah, I think that the code itself looks good. I think it's 10:50 p.m. here, but yeah, tomorrow morning I will try this on my machine, and yeah, I think if things look good, as long as it works on my machine, I think we should be good to merge these and give you the bounty. Yeah, no, these are
Yeah,
really high quality PRs, by the way. Thank you.
Thanks, I appreciate it, and I look forward, if there's any problems, ping me, at me, and I'll help you troubleshoot them. Thanks.
Cool.
Sounds good. Yeah, so I think after that, we want to improve the export thing.
Yeah, I mean,
is
export should
here.
really go into main tinygrad.
Yeah. I think export and annex are the two next things we want to merge into the main tinygrad tree.
Yeah. I mean, like just to be able to do straight up Onyx to exported model, like Onyx to web GPU, just as like a flow in main tinygrad would be great.
Great. Okay. Onyx, I saw the thing in channel. I think few separate things. CI should ideally be future proof, so we don't want any like dynamic things that determine the size or the model you run into CI, because that will break someday. So in principle, having a script that runs a fixed set of models and making sure it works, making sure all the Onyx ops are supported, I think is good enough for less specific bounty. I think we should be close to getting them merged. Since for now, if the only left issue is something is not supported, I see like non-zero in it. So some of these we don't have a good way to support anyway. So having the script, having that ready, then we can think about how to move more stuff from Electronics to main tinygrad.
Yeah, I posted in tinygrad dev what I think the API should look like. We'll create a new folder called front end. Overall, I think the Onyx code is pretty high quality. So we can raise the line limit as appropriate for that. And just like, yeah, tiny like quality of life refactors, it's okay if it imports from Onyx, but it shouldn't import from NumPy. And it also shouldn't take in an Onyx model object. It should just take in a path or URL. So that's done, but.
How do you want to parse Proto?
Oh, we can just import Onyx, that's fine.
Oh, okay.
Yeah, I mean, the Onyx front end needs Onyx and the PyTorch front end needs PyTorch. Like, yeah, whatever.
Cool. Okay. Yeah, let me know if there's anything you need me to review for Annex. Let's push this a little bit so we can have the scripts and like decide how to really move stuff into TinyGraph. Okay. Next we have AMX Tensor Core.
Hi, hello. I posted a question on the channel. I just started the refactor. I couldn't work much last week, but I'm not sure about the refactor you specify, George, where you talked about.
Well, no, but like you load from the regs. Like the UOP is load, right? The same way the UOP is load from define global.
Yes.
Do you like maybe the first thing, like you can think about how it would work right now for ACC. Like right now, we just put the define ACC directly into like an ad or something. But you could
Yes.
imagine a load going there, right? You could imagine it be define ACC, load, and then the ad. And there has to be a load there to load it off of the define. And then the assign becomes store.
Yes, but I think load loads into something, no?
No, load doesn't load into anything, right? Like load just means, so there's really multiple things here. There's global buffers, local buffers, registers, which are things like accumulators. And then there's just the implicit thing, right? So there's not going to be a load and store between, like, say I have like a multiply followed by an add. There's not going to be a load and store there. That's an implicit register. But whenever you have an explicit register, it's fine to have to load from it, like a define ACC.
Okay. Yes.
Yeah, play with it a bit. I really think a load does make sense.
Okay, sure.
Even if that load ends up being a no-op in C-style.
Yes. Okay. Thank you.
RetinaNet. How's your going?
So yeah, so the training, I've already started a couple of them. I think I'm not trying to get the time yet, just down just yet. Focusing on the correctness run. I think we're pretty much aiming towards the target metric. I think I just checked the latest one that I ran. It's just like 0.001. I think it's really close. But it looks like I needed another epoch from 4 to 5. So I'll see if I can hyperparameter tune that just to see if I can get under the 4 epoch run. So that's what I'm kind of working on. But I think the two bottlenecks right now are the eval for sure, because it takes I think like an hour and a half maybe to just go through. I think it's like 20K, probably like 25K images for the eval, and then trying to see if I can optimize more on the forward time as well.
Yeah, so I'm reading you wrong. It seems like so this is 6 GPU, right?
Yes, that's right.
And it's only 77 TFLOPs, so not very impressive.
Yeah, it definitely needs to go up.
Okay. And this one, like this 20, like 30 hours. So I say the most recent round took 30 hours to finish, and you say the eval is pretty close. It might just be noise. But if this round is within 24 hours, is it like finish?
No, not quite. I think by the time it hits a 24-hour mark, I think it's probably evaling after the third epoch. I think that's what I've been kind of tracking.
Yeah, my point is that like everything else seems correct to you, and it's just the timing and the speed is the only issue.
Yeah, I think so. I'm pretty confident with the metric itself, like reaching towards that. So I think it's just really the timing and the speed.
Yeah, so I think one first thing I would try is first I see you have many beam parameters. Just remove those all out. I think those are smaller than default, and you want to see the potential of this. So I would start with removing those. I'll use the default, see if it's faster. Maybe it's already faster with that.
Okay, sounds good.
Yeah. Cool. And obviously, if we want to submit MLPerf, we need to be much faster. But a good round, and seems so. The target metric is 0.34.
Yes, that's right.
Okay. Sounds good. Yeah, just let me we can coordinate on in the tiny box access panel. Just because we only have like 3 green box, and everyone wants to use their green box.
Okay, sounds good. I'll probably stay on Tiny14 for probably, I don't know, like maybe the next 30 hours one more time, and then and I think I can give that up. Someone else can use it.
Is there a reason you can't use a red box?
So it is slower, and also the AM. I think I posted it in the MLPerf RetinaNet channel. The loss, if I use the AM driver specifically, it's like very odd values. I think it's like very large and negative values that I'm getting. So there was also that as a blocker.
Oh, we gotta, okay. If there's some bug in the AM driver, again, we really gotta fix that.
But can you run with AMD backend?
I can actually. Yeah, it is slower. Yeah, so AMD is good. It's just AM that's causing that weird loss values.
So while you are waiting, try to also in parallel run something on AM. I know it's probably taking longer, but eventually we want this to work on both green box and red box anyway, and we have a lot more red box that's idle resource.
Yeah, the red boxes are free. I got 6 more of them too. So there's more red boxes if you want more red boxes. But no,
Okay.
if there's some driver bug, yeah. If there's any way you can find a more, if there's any way you could root cause that would be great too. Like find like one kernel that's failing or something.
Yeah, no, that's slightly annoying because I also had that issue, and I'm pretty sure it's not kernel that's failing. It feels more like the data is not synced properly or something is not copied right properly.
we gotta
because
find these issues.
yeah, there are
It's not a
things like
regular thing. Nimmelgen, you need to we need to figure this out.
Okay. Anyway, yeah, I also have that, but sometimes I retry and it works.
Yeah, we gotta fix
Anyway.
this.
Yes. Okay. Let's quickly talk about the remove compiler stuff from AMD.
Oh, hi. I was doing the LLVM backend bounty recently, and then now we can use the upstream LLVM like LLVM 18 and LLVM 19 to directly compare LLVM IR to the AMD GPU targeter. Now the implementation basically works on Tinybox Red, and the review caused some test failed.
So how sure are you that these are REMU? Because I just read what you wrote, and what you're running on Mac OS is not a real AMD GPU. That's also they're both REMU.
Yes, the test run on test on the Mac is only the test OPS.
Yeah.
And there are other testers on the Linux backend.
So if it's a REMU bug, do you know what the REMU bug is?
Oh, the error choose REMU don't support a new instruction introduced in this kernel. And,
can you just post what the instruction is? Quaslin, can you fix this?
Oh, I will post it in the PR.
Great. Yeah, no, we'll get that fixed. I'm sorry. Once things go to the second page of PRs, I need to be better at just clicking at it and looking at them. But yeah, okay. So you think it's good, but it's just REMU bugs. Why is it taking 14 minutes? Again, it's just the bugs?
You mean the speed is too low?
Well, yeah, it's I see that test taking like a ton of time.
Well, because we didn't implement the local in the LLVM backend.
Wait, what do you mean?
I mean the local support are not implemented in the LLVM render.
Oh. Oh, that should be easy to add, right?
I will
So
try
wait, but
to
I
add.
said,
Try
do you
to
mean
add
like,
it.
why is that not? So you're saying there's no locals? I mean, it's the thing is, it's not really like LLVM. It's really AMD. Interesting. Cool. I'll play with this a bit tomorrow.
Okay.
And I see you set has local equals true. That doesn't work?
No, some instruction, some code not implemented yet.
In Tinygrad.
Yes, in the LLVM render code gen.
Why that is?
I think it's because the LLVM IR was running for the CPU. We don't support the multi-thread stuff. So we lack the local support. But
Yeah.
for the GPU, GPU backend we have the local. So now we want the LLVM IR to support both the CPU and the GPU. So we need to bring the local support to it.
I see. Yeah, no, I mean, we're definitely going to need to get locals working in order to merge this. I'll look into this tomorrow. I don't exactly understand why it doesn't work, but I'll add this to my list tomorrow, and I will post what REMU instruction is, and we'll get that fixed.
Okay.
Cool. Yeah, looking good. You got that boundary locked, so we'll make some progress with this, and I'll give you feedback tomorrow.
Okay. Sounds good. Anything else? I think
Basically, yeah.
overall, making good progress. Torch front end is exciting. So for the people in this meeting, try your favorite Torch script. Try to run it on Tinygraph backend and open issue if something doesn't work, or some open issue if it's something that is not already covered by other things. That is not working. Let us know.
Yeah, let me try to explain this in like really simple terms for people here. So you know how like Torch has different devices, right? You know how you can do like in Torch, you could do like .CUDA or .CPU or .MPS on Apple. So what the Tinygrad backend is you copy and paste these three magical lines, which patches a new device into PyTorch called Tiny. And then you can do .tiny in the same way you do .CUDA. But the thing about .tiny is it uses Tinygrad. So if you have a GPU that only has OpenCL support, for example, if you have a GPU that's like just OpenCL, there used to be no way at all to use that with PyTorch. But now you can use the Tinygrad backend. The Tinygrad backend will take the PyTorch and compile it into OpenCL code, which will run through the Tinygrad OpenCL backend on the GPU, and then pass that back to Torch. So you'll be able to run PyTorch programs with the Tinygrad backend everywhere Tinygrad's supported, which includes some crazy targets like Qualcomm GPUs, Qualcomm DSPs, all these things. But yeah, so hopefully everyone understands what it means when it's like actually go and try a PyTorch program with the Tinygrad backend. The 3 lines are a little annoying. It'd be nice when it's just 1. Actually, I think I'm going to do that. I think I'm going to add that as a file. I think I'll add Tinygrad frontend PyTorch and just make it import from extra.
Then we cannot do a release with that.
No, it won't be included. Won't be included in releases.
Okay.
We won't include that folder in releases yet. But yeah, no, I think just you have to install Tinygrad not from a release. You have to install Tinygrad from source. I'll have it assert. I'll have it assert and say that.
Okay.
All right, that's on my list for tomorrow too. All right, I got a list for tomorrow. Right on the whiteboard. I got LLVM, I got TinyChat, and I got frontend.torch.
Cool. Sounds good. Okay, that concludes this meeting. Thanks everyone. We have meetings every Monday around the same time, unless it's different time, then we would let you know early. And that's it for this meeting. See you next week.